Hey everyone, it's been a cold evening, but I would suggest a warm evening for everyone. Thank you so much for being over here to hear more about 0G's service marketplace. So myself, Gathin, I'm flying in from India. Been super great start at the TBW. Hope you all had a great time and some Taiwanese food if you're not from Taiwan. So even this is my first time at Taiwan, and I find it very tasty and great venue, great audience, and it's been so great till now. So thank you again for joining in today. So as I mentioned, I'm from 0G, DevRel at Zero Gravity Labs. So we are the world's first decentralized AI operating system. So which is a lot of buzzwords and complex words put together in a single line. But I will break down, and definitely by the end of my presentation, you will have a clear idea of what 0G is trying to achieve in the market. Okay, yeah, thank you. So what is 0G? 0G is the decentralized AI operating system. What is an operating system? Operating system is which helps us in orchestration of your interaction with the hardware. Here, the operating system means that this operating system enables you to completely deploy AI models on blockchain and to enable complete suite of AI model deployment, training, storage, fine-tuning, and inference provider completely on-chain to give more transparency and openness, and every output is being verified, and it is permissionless. So to get started with, 0G is a L1 blockchain. So it's a chain with detail. I'll just go into the architecture slide. So yes, this is the complete architecture. And to get started with the comparison, 0G tries to achieve decentralized AI. And this, for example, is a comparison with closed AI. So the first one is closed AI are black boxes. If you are aware of OpenAI and ChatGPT, which we use on your day-to-day basis, the first thing is the agent, model, alignment, the data, and compute. You aren't aware of anything that's going behind the inference and prompt interface that you see. So the complete backside on what the data model is being trained on, who are the computation providers, and what the data is being used for you to provide, whether it's your own data that is being provided, whether the model is actually being provided as an output from the GPT model, or it is being tampered by someone sitting back of the system and trying to tamper it in between the output of what the model has been provided and what the output that you receive. So this is all the negatives that the closed AI has in the current narrative. And currently, we're just getting started with using multiple AI agents. Now there has been a lot of AI agents interacting with each other. Then think of a future when everything, including your automobile, your home, your day-to-day activities, everything is run by AI agents, and you have no control of your data, and you aren't aware of whether it's being tampered, is someone manipulating the data, or it's actually given output by an AI model. So to solve all those issues in the upcoming days, we provide a complete operating system for you to decentralize the complete AI model infrastructure. So that includes 0G chain. We are a L1 modular blockchain. So that acts as a base layer which runs on top of a deepened hardware. So the next part, you could see three sections. That is the data availability nodes, storage nodes, and the compute networks. So starting with storage network, we have an inbuilt decentralized storage network which has the throughput to handle large AI models to get them being deployed on-chain. So I will dive deep into what each are in the upcoming slides. The next is the data availability layer. Data availability layer, as you are familiar of with other protocols, which takes in the data from the data heavy from the L1 chains and store it off-chain, which is verifiable at any point of time. So we have an inbuilt data availability layer and also a compute network, which we just launched recently, on which you'll be able to train data models. You will have RAG, and you can also deploy AI agents. So on top of these, we have something called as service marketplace, which is where you can think of it as like a marketplace where you'll have a lot of providers providing you the service of their AI agents and their GPU supply, through which you will be able to interact with the inference providers. So then we have the alignment nodes, which we did the node sale recently, through which we give the decentralization power to our community members. We sold around like 72,000 nodes. So the primary goal of alignment node is to check whether the 0G storage nodes, DA nodes, are performing as intended without any manipulation. So that being said, this is the rough idea of the complete architecture, and I'll deep dive into DA, storage, and chain, and we'll go in clear bit architecture about the service marketplace, and I'll give you a quick demo on how you can get started with that. So about the 0G chain, it is an AI-optimized, scalable L1 blockchain. Our prime goal, as I mentioned, is to bring on-chain AI, where the sole focus of our blockchain is to enable that. So we are a modular layer. We have separated the consensus, execution, and the storage layers to enable high throughput, and also for scaling each and every unique part of the modular chain, and we are infinitely scalable. What do you mean by infinitely scalable? That is, as the demand increases, you will be able to increase the number of nodes in the consensus networks to increase the throughput and also to cater the demand from the user's end. So the next is that we are EVM compatible for effortless DApp integration. But we are looking forward to a future where we are completely chain agnostic. So the next unique features is that the modular scalability for AI, as mentioned, and we have a custom consensus network, and we use, oh, there is some error on that. OK. So we use something called as Pora, which is a consensus network for our storage network. So I'm not sure the error, right? Yeah. I'll keep continuing. Like the shared staking, you will be able to share staking among different node providers on a network. So that's regarding the 0G chain. Excuse me, can you? Yeah, thank you. Awesome. So you could see the testnet statistics right now. So it's on our testnet version 2 right now, and we have around 600K wallets. We are 67 times oversubscribed. We have 6,000 storage nodes running by our community members, and we have processed over 1 terabyte of data. So next is the 0G storage layer. So as you can see, we have DAI applications, which needs massive data sets, large models, and AI-generated assets, which needs to be stored somewhere. But we are enabling that to be stored completely on-chain on the 0G storage. So the first one is that our storage is sharded, and it is done using erasure coding. Using erasure coding, the data is split into multiple chunks, and it's distributed among our storage network. Next is that we have parallelized consensus. That is, we separate the data into multiple chunks, and it is parallelly streamlined, and it is sent to the storage nodes. So this 0G storage enables fully on-chain AI data, and it helps in verify data, model, and assets. Since all the data are uploaded onto the 0G storage, you will be able to verify the data's integrity. And also, we have currently did a record of providing 1.87 Gbps per consensus layer, which is like a world record in on-chain 0G's on-chain storage networks. So next is high-performance AI use cases. As you might know, AI models are so large-scale and have like terabytes of data. That being completely stored on-chain is like super intensive on the blockchain to work on that. But our storage network is completely designed such that it will be able to handle such a high throughput of storing large data sets on-chain. And it's integrated in the cluster of 0G's modular architecture. So when you try to use and provide inference, or you use the data availability layer, you will have an inbuilt storage. So that comes under the name of zero gravity. That is, we make it so seamless that we provide the complete toolkit of architecture. That is why we call ourselves as the operating system for AI. Next is about the data availability layer. We are the first infinitely scalable data availability layer. That is, you will be able to add more number of consensus nodes to increase the scalability, as I previously mentioned. So that being said, our data availability layer is completely programmable with high throughput and efficiency. So that we are able to achieve by separating the tracks of data storage and data publishing. For those who aren't aware of what exactly DA layers solve, is DA layers abstract the storage of high intense data onto layer ones, rather than storing it somewhere off-chain, which is accessible at any point of time, and also it is verifiable on demand. So this is useful when you want to verify. For example, you interact with a meme generating model on 0G, and that fetches data from the AI model. But at that point of time, you want to verify what the training data was used on, and you want to check the data and transaction history of that particular block. So for that, that complete data need not be stored on L1s. So for that, you can store it somewhere on a data availability layer, which is exclusively used to store and store data blobs of the transaction history of chains. So I would dive deep into the architecture in a detailed architecture diagram, but for now, you could just think that we have two different lanes. One is the data storage, the other one is the data publishing. So I would like to just give a brief example on how DA works. So in the use case of L2s, we are currently partnered with Polygon, Optimism, Manta Network, for example. And on layer 2s, executed transaction blocks needs to publish the data for light client verifiers. So one is for AI training verification. The other is for the light client verification of data. So there are two things when you execute a transaction on layer 2s. One is the data proof. The other one is the transaction history. The transaction history is the work that is put in to get the transaction settled on the blockchain and the complete transaction details being embedded into one hash. The proof is the complete transaction hash, which is it's a proof if it's a ZK rollup, if it is a transaction hash, and if it is an optimistic rollup, for example. So this proof needs to be stored as a batch. Multiple proofs are aggregated together, and that batch, the proof for that is stored on the L1s. But that transaction history technically need not be stored anywhere. But for the use cases that I mentioned, for AI verification, for light clients, for example, if you have incentive mechanisms of historical contributions, for that you need a DA provider like 0G for later verification. So that being said, that is how we solve the problem of data availability in the market. This is our architecture of DA. I'll just give a high brief overview because we need to dive deep into the compute service marketplace. So when the client uploads the data and that data is being spread into erasure coding, that data is split into multiple chunks. As I mentioned, there are two parts. One is the publishing layer, the other one is the storage layer. That data chunks are dispersed into the 0G storage network. And that being said, the data is stored randomly on the storage network. And the nodes that receive the data chunks sign the data and sends to the 0G contract that is present in the 0G chain, which contains the Merkle root of the complete data storage. And that gives the complete commitment proof to the smart contract, and the final ZK proof is submitted to the L1. So that is the overview of how 0G DA architecture works. Starting with the 0G service marketplace, and we will be diving deep into this. And this is a super interesting topic that is not being yet in the market, but we solve the big issue that is available, that is the service marketplace for DAI models. So this is a quick example on that is the 0G consensus, and that is the 0G chain, which has the smart contract. And the 0G storage nodes contain all the model and the data that are required. That's our CEO, Michael Henrich. For example, he's the client, and he requests the 0G storage for the models that are present in the 0G storage for a particular output. The output is being given as a verified output using OPML, ZKML, and TEML, and the complete payment is settled using the 0G smart contract. So I'll dive deep into each part of how this architecture works in the upcoming slides. So this is the 0G compute network. So as you can see, the first part is providers, who are the sellers, and the next part is the users, who are the buyers. So the providers, for example, if you are a provider of a model, if you have a Llama 3B, for example, you come into 0G and you give all the service provider data. For example, what is the cost, what is the service that you're providing, what is the URL to access the model. You upload the model onto 0G storage, and you share all the details, and you register as a provider on 0G. So once you register on 0G smart contract, the next is the user or developer who wants to interact with your inference. He would pre-deposit a certain amount of fee to the smart contract, which will create an account which is paired to the provider. So the next step is user will send a request with signed metadata to the service provider. So it's like user is requesting on what should I do? Like, for example, any input that he'll give, for example, if it's a Llama 3, what is the super interesting places in Taipei? Maybe the input. What the provider will do is it will generate the output and also it will submit a ZK proof of that output and that will be verified and also it will check whether the user has the balance. And if all the things are checkmarked, so then it sends the output back to the user and it gives you the thing whether it's verified output or it's a non-verified output. What do you mean by verified output? Verified output means that the data was not tampered in the progress and it was completely provided by and genuinely provided by the model only, and there has been no interface in between the track. So I will show you a live demo on that in the end of this presentation. So this is how, as a provider, you could register into 0G. So we list, you can register, you will have the GPU and you register onto 0G and you provide in all the details. So once you register, we have a lot of GPU providers on top of us whom you could utilize for the model computation. So as a provider, you register on the service provider and the model is stored on the GPUs that are available, which takes care of the computation. So for the inferences, we have 3 types of inferences currently. That is OPML, TEML, and ZKML, which will be launched soon. And currently, OPML is for crypto-economically and game theoretically secured, which is the simpler version of the inference. The next is secure TEML. TEML executes in a trusted execution environment in a chip such that it is not tampered by any outside data during its execution. And ZKML is based on ZK proof, which is upcoming. So these are the choices of inferences, and whichever inferences suits your model or the provider. For example, if you're a healthcare provider, then you would suggest that no one tampers your data, so you could use TEML. So if you're just a model for meme generation, for example, you could use OPML for a faster execution and simpler inference interface. Next is the payment settlement. So you will have 0G tokens, which you will deposit on the smart contract, which would be auto-debited based on your usage with the providers. For example, there are around like 10 models. You no need to pay for each transaction. You'll just deposit an amount forefront to the 0G contract, which would auto-debit based on the usage of your model. So as this is the same as the previous slides on the GPU provider interface, and that is where user deposits the 0G tokens, and it will get auto-settled after the ZK proof generated from the providers. So this is the current roadmap. In a service marketplace, we have provider registration, developer service, and payment settlement. It's up. And storage network, it's completely available for you to store data sets, assets, and models. And for the compute network, we launched the inference and the training, on-chain training and on-chain agent deployment. We will be launching it in the first quarter of next year. So that is similar to that. We have the storage network, DA, that's the complete architecture I discussed prior. As I mentioned, the training, RAG, and agents, and vector storage of vector type data storage will be launched in next quarter. So currently, we have 2 bounties for total of $5,000 for TBW Hackathon, if you are interested in. So the first one is building custom rollups with 0G DA integration. So as I mentioned, we have a DA layer. So all you need to do is spin up your own custom rollup. It may be OP Stack or ZK. And you need to integrate 0G's DA layer and perform a few transactions. As simple as that, but we have some good and cool ideas that we would like you to pursue on that. So the next is DAI application development. On DAI application development, you will need to use the compute networks, which is the quick demo that I'll be showing you later, and use our providers. Currently, we have Llama 3B Instruct that's deployed on 0G's compute network. So you could use that and create a DAI applications on top of it. So let's go on a quick demo. So we have 10 more minutes. We'll just go on a quick demo. So this is 0G's compute networks SDK. So I'll just go a quick run on this. Like, how many of you here are developers? Okay. Okay, then we'll just make it a bit high level. So that you just importing necessary packages, and 0G serving broker is the package that has the complete integration mechanism with the compute network. Step one is you are creating a wallet. You could use Ether's wallet or browser providers. Here, I just connect with my private key and create a wallet instance. Next, you are initializing a broker. The third step is you are listing all the services that are available in the 0G compute network. Currently, we have 2 storage providers. We launched it a week ago, but by this end of month, and we are looking forward to see from all our partners and all your developers to register a lot of provider and deploy your models on top of 0G. The first is you list all the provider services that are available. Then you select the service that you would like to see. For example, I selected a provider called as Chat Provider 1, which is a Llama $8 billion parameter model. So I'll show you the output on what is the output that you get when you run each of these code sectors. Next is you need to create an account which is paired to that provider. So you deposit an initial balance of so cheap that is it is like 0.0000001 A0GI tokens, which is extremely cheap for you to get started with. You just need to deposit this testnet token, which you could get through our faucet, which is available on the links that are in our website. After that, you can initially send the total number of tokens that you want to deposit, or you could just, again, deposit funds into that account. This will create an account pair with that provider. Next is that we are going to use the provider service. So now you are connected with the providers. Next thing is you are getting the endpoint and the model details from the provider, and you're also getting the header request on how you will pass in the header request to an OpenAI standard message fetching. You could use direct fetch, or you can use OpenAI's SDK for you to fetch data from 0G's storage. So sending a request to the service. So as I mentioned, I just fetch it and give the endpoint. I just pass in the endpoint, the header, and the model. And if the response is not OK, it will shoot an error. If it's completed, it will get the JSON file, and it will get the content or the response that the model provided back. Last is it processes the response, and it will tell whether the response is valid or invalid. For example, if there are like 2 things, if 0G has a cool panda mascot, so if I ask 0G, if you ask an inference on, can you generate a 0G panda mascot? And it will give you 2 outputs, for example. One output has a small Nike logo. The other output is without a Nike logo, and it's a proper mascot. The first one, you'll actually get it as invalid because it was tampered by some third-party provider, and they placed in their branding in the output. While in the other case, it was just providing the 0G's mascot. So it will give you the proper verified output such that it is not being tampered in its output generation. This is the output. So first, it lists all the available services. You could see that there are 2 services, Chat Provider 1, the next is Llama 8BB. So I selected the first provider, which is a chatbot, and which is Meta Llama 3.18b instruct model, and you have the API endpoint. The next, you could see what is the provider's address. Then after that, you get a result of the account, of what account is being created with instance of your wallet and also to that provider. Next, it processes the request, and I asked in, as you can see, the content that I asked as a request is, what are some unique places in Taipei? So the output that I received is Taipei, the vibrant city of capital, and I got the complete output from the Llama model. So, and you could get the response validity as valid. That means it is being tamper-proof. I wanted to show how quick it is. It just took around like 4 to 5 seconds for it to generate the output and also verify it using TEML, and also get the fee and submit the ZK proof. So it's super fast and super efficient, and you will also be able to get verified output. But there is no provision to do a live demo, so I just quickly give this snapshots of the complete demo. So this is the complete demo of like what 0G does, what is the different structures and layers of our architecture, and a quick dive into our compute network. Thank you so much, and this is the link tree for 0G, and if you'd like to connect with me, say hi, and that's my link tree. Thank you so much for listening in. I'm looking forward to see you all build on top of 0G. Thank you.
Awesome. Thank you so much.